Hey everybody. I've got a few minutes of some hints and tips here about how to really do this simulation well. Um, this is the page that you'll come to when you open up the ramp, and you'll want to select the Introduction tab, and it sort of looks like this, and it has a graph here and so forth. But let's step through looking at the settings that you'll want for for this. All right, so let's make sure we pick the filing cabinet. So we'll go back here and we'll pick file cabinet. And what else do we need? We need to select the idea that it's frictionless. So we go over here and select frictionless. You'll see it start to move. And you got these graphs going on here. And I would also, by the way, turn off the sound. I've got the sound on my computer turned off, but I would turn off the sound and make sure you're not disturbing people. What else? You'll want to set the position to 15 meters. That means you can just drag this over here and move it up to 15 meters. But you see it's kind of going to fall no matter what. So maybe it's best to hit the pause button so it's not running, and then set it to 15 meters. Okay? So there's that. We also want to set the angle to some low value, anything between 3 and 7 degrees. So now I can go over here and I can pick 5. And that's between 3 and 7. You see it says 5 there. And then finally, what else do we need? We need to pick the energy graph. So right now you've got this parallel force graph, which that's not what we want. We want to take away that, and we want to just select the energy graph. Okay, the energy graph is going to help us figure out like when the potential energy is 0, and it's going to be really helpful for us to take care of business. Okay. Let me pause for a second, and I'll come back with some thoughts about how to transition from, say one trial to the next. Hang on. If you notice your data table on the handout, there is the first data table is about observing what happens with the cabinet, and you'll notice that you're going to have to get the potential energy at the top, the kinetic energy at the bottom, the velocity, the distance, the acceleration, and finally FP. That may seem a little mysterious right now, but let's take a look at some of the simpler pieces, okay? Let's look at the potential energy at the top. We've got our object set here. I would clear all of our graphs, okay? And so we're ready to go. We're at 15 meters at the top of the ramp, frictionless file cabinet. We can see all that happening here. Our total energy is 1281 joules. Our potential energy at the top, 1281 joules. So in your table, you could put 10 degrees, 1281 joules for potential energy at the top. Now, we'll go ahead and run it, hit this little go button, and the cabinet will start to roll down. Potential and kinetic energies will exchange for one another, and off it goes. Now, I've intentionally let it hit the wall here for reasons I'll get into maybe in a little bit. But once it hits the wall, you can hit the pause button, and you can get the kinetic energy at the bottom by sliding this slider out to the point where the potential energy in blue just becomes 0. So it looks like right there it becomes 0. Okay? The potential energy is 0. Now the kinetic energy at the bottom is 1283, and life is good. You can put in your kinetic energy at the bottom. Really, we're doing that just to make sure that we're starting our cabinet at the top, and we're looking at its velocity at the bottom. We could, from the kinetic energy, we could calculate the velocity, but we've got a somewhat easier task here. Right over in the corner here, there's a velocity. It's negative because it's going downhill, but we could record it as positive. And we could just write 5.07 as our velocity right in here. Okay? So that is trustworthy up there. But this time is not trustworthy, and there is a note about this on the handout. So whatever that might be saying at any given time, pay no attention to it. It is not to be trusted, okay? You're going to use the velocity at the end of the ramp, and you're going to use the fact that the ramp is always 15 meters long, and on the handout there's a way for us to go from this velocity and distance information to calculating the acceleration, okay? And you'll have done some previous work so that you can go from the acceleration to figuring out what the parallel force is. And so there's a little bit of effort here for any given trial, but you'll have the angle, the two energies, PE at the top, KE at the bottom. You'll read the velocity, you'll know the distance is 15, and you can use the formula to get A, and then your own thinking to get FP. All right, I've got one more thing to share with you, but I'm going to take a pause for a second. Okay, I'm back at the simulation, and I like the simulation a lot, but there's a couple of things that are a little bit clunky about it, and maybe you're going to figure out some better ways to work with it than I have. But as I've already said, the time is not to be trusted, so don't trust that. The other thing that you'll want to do is you'll want to be able to get back to the top here. You want to be able to repeat your trial maybe, or change an angle. But before doing that, what I would say is make sure that, there we go, make sure that you your device, whatever it is you're looking at, has come to rest, and you can see that by looking at the velocity up there, okay? And you pause it then, and at that point, now that it's at rest, this is a good time to clear your graphs, okay? Potentially change your angle. I'll go to 17 degrees here, hit enter, and now I'll slide my device back up to the top, okay? That sequence seems to put you in a good place where you've got a new total energy, a new potential energy, no graphs are showing, no energies are showing here, and you're ready to hit go again, and off you go. So it slides and hits that. You can hit pause. You can figure out where the 0 point for potential energy is and the maximum kinetic energy. You can get the velocity. That gives you acceleration and FP. And then hit, if you're not at the wall, if you're not stopped, make sure you're stopped before you clear graphs and try anything new over here. Okay? That's really kind of critical. You don't want to bring it back up to the top. There are sometimes you can get it back up to the top and the velocity is not 0. We definitely want to have an initial velocity of 0. Okay, good luck with everything, and I'll see you on Thursday.